For one of my robotics projects, I use Raspberry Pi 4 and some software on there called ROS to control the robot. And it's running quite slow on the Raspberry Pi 4 due to all the different processing needs that are going on there. So I've got a Raspberry Pi 5, which I'm going to be upgrading the robot to, and hopefully should see around about a 3 times performance increase. But just before I do that, I want to see actually one of the software, how quickly it runs on the Raspberry Pi 4, so that when I upgrade to the 5 I can see the difference. So today I'm going to go through some benchmarking and basically run it on the 4, so that when I go to the 5 we've got some basis for comparison. So here's the car in question. This is my autonomous vehicle. The Raspberry Pi 4 is not fitted in there at the moment, it's just here on my bench. But I'm going to go through some of the files that I've used to generate this benchmark, so you've got a bit of an understanding what it all is. So for this I've created a little project, and the main purpose of it is to take this MCAP file, which is basically a pre-recording of a load of data of a SLAM session that I ran on the Raspberry Pi 4, and the URDF, which is the description of the car itself. So this is the URDF. It's basically an XML file that describes all the parts of the car and where they are relative to each other. And we've got a little preview of what that looks like here, and as I'm sure you'll agree, that looks exactly like my real RC car. In the middle here, you can see lidar. Underneath it is an IMU, which I haven't got fitted yet, and a camera, which I have had running before but is not on the car at the moment. The main donkey work is being launched by this file, which basically takes the URDF and the pre-recorded data and runs it all up. We've got a couple of other things in here as well. So we've got something called the Foxglove Bridge, and this is just a node that allows the data to be rebroadcast and viewed in a software application called Foxglove, which I'll show you in a minute. The software that I'm actually benchmarking is this one. It's called the RF2O laser odometry, and what this package does is it takes sequential lidar scans and then turns those into a motion model of that can then be used for the odometry for SLAM. So it basically takes sequential lidar data and from the computes how far the vehicle's travelled. So we'll get into running this in just a moment, but let's first look at some of the parameters I'm using for the bag file. So the bag file, as I mentioned, basically contains all the data from a previous session. So we've got some parameters here that we're using to play the bag file out. I don't want to play all the data that was recorded in the bag. So here I'm just specifying I want to play out the scans which are recorded from that lidar scanner I showed you, which then get fed into the RF2O package. I'm also playing out the clock, and that's required basically because the data was recorded a while ago, and because of that some of it could be discarded if I'm not basically due to its age by the different packages. So this clock enables me to output the time as if it was now, and in the launch file we've got various packages here which are using sim time. In other words, they're going to read the time from that clock rather than using the real clock. So hopefully that's a good description of what I've got going on in this benchmark, and so now let's go and run it. So I've got the launch file ready to run here, and all we're going to do is call ROS2 launch. That's my package name, and then the car.launch. Let's give that a run, and then I'll bring up the Foxglove and you can actually see what the data is. So as that plays in the background, should be able to see here the laser data that we've got coming out of the scanner, and over here is a bit of a jumble, but here we've got the odom frame and the laser. So as you can see, the car's actually moving in the map, and this odom frame is staying still. In other words, it's not travelling with the car, and this is precisely what this package does. Is it is working out how you've moved relative to where you were a moment ago, and to try and do that, and to try to keep the relative pose basically from where you started. So we'll just let this run a little bit. So here's part of my house, and in a minute you'll see that the car's going to move over to here. Let's see if we can just make those scan points a little bit bigger. There we go, that might work a bit better now. You can see me moving around here, and as you can see, it's still tracking this odom frame pretty well, even though there's no IMU or any other sensor on the vehicle whatsoever. There's simply just the lidar scanner. Okay, I'm going to close this down, because that's basically the end of the data, which is not so much. I'm going to run it again, but this time I'm going to run it with Top running in the background. Top is a Linux application that can basically tell you what processor are running, what the memory they're using is, and the CPU. And of course it's the CPU that we're interested in. So I'm going to run the application again there, and switch to this bottom window of my workspace. And when I run Top, I'm making sure that I only look at the RF2O laser odometry package. So here we can see it, and you can see that the CPU is about 36%. You can also look at the memory, it's very small. If I press M here on top, we can look at the memory overall in the system, and you might notice that this is saying around about 36 to 40% CPU, but there's a lot more going on in the system. Even despite that, the CPU here is saying 10%, but that's because this Raspberry Pi 4 is a quad core. So if I press 1, I can display all the cores, and now you can see that for the majority of the time, this task is basically taking up it's running on one core, and it's taking up quite a bit of the CPU on that one core. So when I get the Raspberry Pi 5 up and going, I've now got a bit of a record so that I can compare, and based on the stats online, the Raspberry Pi 5 should be about 3 times quicker than the 4. So this 30 to 40% should drop right down to something like 10-12%. So I'll do another update video when I've got that, and we can see what the difference is. Thanks for watching.